So let's look at these two examples. Now the first one we're looking at already has single log by itself on one side, number on the other. So this means we can take the base, raised to the power of the opposite side, equals the argument. Now to solve the resulting equation, we look at this and say, hey, this is quadratic, so let's move everything to one side so that the other side is 0. Then to solve a quadratic equation, we try to factor. If it's not factorable, we use quadratic formula. Now this one actually is factorable, so we're going to factor it as x minus 3 and x plus 2, meaning either x minus 3 could equal 0 or x plus 2 could equal 0, meaning x could be 3 or negative 2. Now both of these answers are in fact going to work, but I do want to tell you that when it comes to logarithmic equations, this is going to be a case where we should check our answer to make sure we didn't get an extraneous solution, an extra one that needs to be thrown out. And what we're looking for is we need to make sure that whatever answers we get make our arguments positive. Because remember that we can't take the log of a negative and we can't take the log of 0. We can only take the log of a positive number. Now this x equals negative 2 was fine because the argument was positive. If we looked at plugging negative 2 in, we would have negative 2 squared minus negative 2 on the left, so that would be 4 plus 2. And log base 6 of 6 really does equal 1, which is what I was trying to equal. So that negative 2 really did work. And quite frankly, the only thing that's going to run us into problems is this second example, when we have to use a property of logs. So when we use a property of logs to make a single log, that's when we got to be careful. So on this one, we're going to use a property of logs to write this as a single log, making this log base 3 of x times x plus 6 equals 3. Then we can take the base, raise to the power of the opposite side, equals the argument. Now, since this is quadratic, we can move everything to one side. So we're going to subtract the 27 to the other side. And then we're going to factor. And this factors as x plus 9, x minus 3, meaning x plus 9 could be 0 or x minus 3 could be 0, meaning x could be negative 9 or x could be 3. But remember, what we want to look for, what we're double checking, is that in the original problem, that none of our arguments were, to be technical, non-positives. We want to make sure that the arguments are in fact positive. So if I were to plug negative 9 into the original problem, that argument would be negative. So as we saw in the first example, a negative answer isn't a bad problem. It isn't an extraneous solution. The problem is when an argument becomes negative. Now when I plug x equals 3 into the first argument, that's positive. When I plug it into the second argument to get 3 plus 6, that's positive as well. So x equals 3 is perfectly fine. Now it is possible to throw a positive answer out as well. So I just want to point out that if your original problem had something like log of 2 minus x, and you got x equals 3, that would get thrown out because your argument was negative 1. 2 minus 3 is negative 1. That would be bad. So what we're looking for is we're making sure that the arguments in the original problem are always positive. That's what we got to be careful of. That's what we got to look out for.